Okay, folks, our next talk is a panel about the MDRS analog suits that we use at the station. Now, this has been a labor of love by one of our chapters, the Northern California chapter, for many years. The effort's been led by Scott Davis. And as Scott and Judd are bringing over some of our gear, I'll just tell you that these suits go through a lot of wear and tear every field season. Crew members use them almost every day when they're in sim. They ride in the rovers with them. They explore all around the MDRS, and so as you can imagine, they get scuffed and scratched and things on them break. But what Scott and the other volunteers at the NorCal chapter do every year is completely refurbish them. They augment them. Every year they're better. Every year they're more advanced. And so they do a fantastic job. So I'd like to welcome up to the stage Scott Davis and Judd Reed. Judd is someone that's been involved with the MDRS program for many years as well. And then we're also going to invite up a third person, and that's Peter. Now, Peter is a mad scientist type. We included him on this panel late just because the work that he has done on his own is just phenomenal. And while this is not officially yet part of the Mars Society, it's in the same spirit of what we do with our analog suits. And so welcome to the stage as well, Peter. Peter also is going to be part of this panel, but then he also has a solo talk that we'll segue right into when we're finished with our initial remarks.
So I prepared this little deck just sort of to give a framework to our discussion. It is certainly not a presentation, and for this to be successful, it's going to require more from you than from us. But I wanted to kind of outline what we've been doing. For this deck, I've got a brief history of sim suits at MDRS, and then a closer look at how air flows through them, and finally a suit that I've built to help us quantify the performance of the older ones. So here, this little table shows the history of sim suits at MDRS. The original set lasted for nearly a dozen years. And then when those were at near end of life, I was trying to maintain them and couldn't. So I built a few suits to fill in the gap until we had a new design and a stronger version. Those didn't last very long, and we got the in about 2004, we rebuilt based on the old design, the suits that you're seeing sitting in front of you. Those are still in use, and I'm missing something. Oh, while those intern suits were being used, I built a prototype of the suit that's sitting there with the single piece suit. My motivation for that was to make it easier for me to maintain the other ones. And then we started the reset where we had a new implementation of the original design, including the one-piece suits. And then for many years, Scott and team have been making incremental improvements to that set of suits. And finally, I have the colorful one sitting there is one I built just for testing. And we have no idea what's coming next. Well, we have some ideas, but they're not ready yet.
Excellent.
So these are the original suits. The photographs are actually from FMARS, where the suits are identical to the ones used at MDRS. And these are the ones that lasted for a decade. The picture on the right shows the basic airflow through them. There's two computer fans inflating a dam in a storage container, and a couple of tubes flowing into the helmet with air vents coming up. So there's positive pressure on your head, and then that leads to venting around your neck and out the back. Next.
And from what I understand, these particular suits here are still at FMARS, from what I
I
understand.
believe so. Yes.
Yeah, so we'll be hopefully using them again next year.
So then I mentioned that I built an interim suit. This is functionally very similar to the ones we were looking at, but the storage, the pressure chamber, the dam, which is really just a Tupperware box. I shrunk it so that it was less vulnerable and put it in a wooden, or in some cases a PVC framework. Also, you see that the dome is a single piece, and that had the disadvantage that air could not get out through the top, but only through the bottom, as shown in the graph on the right. Next. At about that time, or just after that, I built the prototype suit for the prototype for the one-piece suit. And as you can see, it's a pretty crude single frame, has the same components as the one I just got done showing. And it is still in use. That wooden frame was covered in canvas, and occasionally we have to stop and tighten the canvas, but other than that, it's been running for many years. And so those suits were used for, I think, a few years, but were not built of the same quality as the ones we had either before or after. So we got some new funding and started over. The NorCal chapter rebuilt based on that design. The ones just in front of us, they have a much stronger box, similar design helmet, but all of it sort of re-engineered. And the same airflow as it had originally. Next. That seemed like just another view of the same.
Yeah, it was another.
Yeah. We also redid the single piece suits. The view at the top can contrast the prototype on left and the current one piece suit on the right. The balance of these pictures show the various stages of our construction. As you can see, it's a wooden cabinet with a metal hood over it.
Try to talk right into the mic.
No, sorry, I can't talk forward and look backwards. Since that original implementation, Scott and company have been working on incremental improvements every year, because every year he gets new information about what failed during the year. He's re-engineered the collars, which are now 3D printed, swapped out the computer fans for centrifugal pumps, changed filter positioning, and a host of other small changes. Over the past, over the summer, I built the colorful suit on the far left, or lying on the ground on the far left. This is not a prototype of the future suit, but rather is a test platform where I will be able to measure temperature and pressure and humidity throughout the airflow to determine whether reconfiguration of how the air flows through the system would help or not. That system is modular enough that I can configure it in many ways. And the graph there shows the most complex method that I've tried. Starting at the bottom, air enters with the brown arrows, passes through a centrifugal dust separator, rises through on the blue arrow through a heat exchanger with a pump at the bottom, and then again a pump at the top, injecting it into the helmet. Then the whole process runs backwards, of course, pumping air out of the helmet through the heat exchanger again, where it will cool, and on out through the exit. The stars on that graph represent the location of all the sensors. In each location, there's a temperature, pressure, and humidity sensor. I've also got a little 4-button keypad, which is actually a larger keypad that I've masked down to just 4 buttons. And there's audio commands that give you feedback. So it was an easy way to build the interface with neither a display nor a full-fledged keyboard. The main concern, the reason I'm interested in these measurements of pressure and temperature, has to do with the flow mainly. And I wanted to stress that these are not very big pressure changes. So I've graphed our current location, MDRS, and then MDRS with a suit on, so your pressure at your head. And just for fun, I threw in the highest landmark nearby, which is Factory Butte. So in effect, when you're at MDRS with a suit on, you are about as far below the ambient pressure there as you would be above the at the equivalent elevation of being at the top of the butte. The right part of that shows why we care about this. The origin of the arrows is the air coming out after your breath coming out, and of course it cools quickly, and the pressure drops along the blue arrows. And what matters is whether you're on the high or the low side of that dew line to keep the faceplate from fogging. I've described it as being reconfigurable. These two graphs show that you can swap the heat exchanger out and have just 4 fans running through it with, in a sense, the pressure reservoirs. And I can configure it for both fans injecting air in parallel or serial, or one injecting and one extracting air. So the pressure at your head is ambient, and various other configurations.
That's the last slide.
That's the last. Yeah, that was the whole.
Thank you, Judd. So Scott, maybe you could tell us a little bit about your experience with the suits and anything you'd like to add.
That sounds good. Can you guys hear me okay? Excellent. Yeah, I'd like to kind of show off the suits and talk a little bit about the history of them. I believe it was 2016 when our chapter was asked to develop the new suits.
I'm sorry.
Okay. Like the first.
Yep, going back.
Yeah, I might have the date a little off on that. Anyway, so with very rather limited budget and a limited time frame, we put together what we call our 2-piece suits and provided them for the upcoming season that year. So the 2-piece suits have the helmet and the backpack separate, and it's got a shoulder ring that can be separated from the helmet, and the shoulder ring attaches to the frame of the backpack, and it loosely attaches, so it comes down over your head, and then the helmet can be placed upon it and latched onto it, and then the helmet attaches, the air tubes attach from the backpack to the helmet, and that's different from the 1-piece design where the helmet and the backpack are all basically one piece. So we have we developed 6 of these 2-piece designs the first season, and then for the next season we developed 4 of the 1-piece designs. These were based on Judd's prototype 1-piece suit design, and we made them a little bit larger and kind of gave them a nice fabric cover. Both of these designs were pretty simple and made heavy use of existing hardware where we could find it to make it into a simulation of spacesuit. And we were going with trying to provide the experience of wearing a suit on Mars. We can't simulate everything on Mars, of course, just like at the MDRS, they can't simulate radiation and air pressure and light levels outside that you would have on Mars. But we are simulating the bulkiness, the difficulty of doing EVAs, the sense of being in an enclosed environment, limited field of vision, limited ability to hear things around you, which affects communication, and the difficulty manipulating and interacting with things while you're wearing the suits. And through these experiences, the crews get an understanding of the challenges involved and learn to work together and overcome and get used to these challenges and familiarize themselves with them. And we also wanted our suits to be able to, in emergency situations, where they need to break simulation. If somebody is sick, if they pass out or anything like that, to be able to remove the suit quickly out in the field and to provide first aid medical support for that crew member. So we don't want anything in the suit to prevent that from happening. We want them to be able to pop the suit off very quickly in an emergency situation. So the suits are made out of, for the most part, simple, straightforward hardware parts. The clear domes are made of acrylic, and there's a company we work with that provides these. They generally make them for like security camera domes, and they're also used in RVs and boats and other places where clear domes might be needed for a particular design. And the backs of these two-piece helmets are made from trash can lids, common rotatable trash can lids. And they have worked quite well.
They have worked quite well for 20 years.
Yes. Wow. So another part of this design for these suits is not only are we trying to simulate the suits, the weight and the bulkiness and the difficulty of suits on Mars, but also they have to be very robust, because they're dealing with a lot of wear and tear, and they have to be simple enough that crews can learn to operate them pretty quickly, because these are crews that generally they'll have 2-week crew times, and we often have like 12 crews for a given crew cycle each year. And so there's a lot of different people wearing them, and the crew engineers have to be able to troubleshoot them, repair them, diagnose the problems, and some engineers on some crews are more experienced than others and are better at handling these things. So we also provide technical support for the suits over email to try to keep it in simulation. And so we started with things fairly simple, and we've made kind of gradual improvements to the suits of the seasons. We originally had, for the shoulder and neck rings, we originally had these big PVC pipe couplers that we had cut into the pieces, but they were extremely heavy. They're about twice as heavy as these. And we've later replaced them with 3D printed shoulder and neck rings. Hopefully these ones are freshly printed, so I hope they will last this upcoming season nicely. We'll see. And for the one-piece suit, it is largely made out of aluminum sheets, plywood, aluminum angle brackets. A lot of it is riveted together, and both the designs use very simple electrical circuit with PC fans, originally PC fans on the two-piece. We've later changed them to kind of squirrel cage blower fans that produce a higher pressure output. And we've added kind of a fan speed adjuster on it, so crew members can actually modify this fan speed out in the field. And the one-piece suit still uses PC fans, although we've changed it to a higher speed, quieter fan from the original ones. And I believe the original prototype suit that Judd developed, that's still being used at the MDRS, uses the original type of fans.
That's right. It's identical electronically and well, it's identical in almost every way to the corresponding two-piece fund.
All of the suits use the same type of lead acid batteries, 12 volts, very simple and inexpensive, and they are rechargeable. We always have extra batteries there. We were looking this season into maybe changing over to lithium power tool type batteries, but we just did not have the time to make the changeover on it. It would involve a little bit of changing out the electronics. So we are still sticking with 12 volts for now. The nice thing about them is they are very robust. They are not prone to catching fire or anything. And they, well, it's very important for a suit. You do not want battery fumes or smoke or anything coming through the air system. And they can handle the temperature ranges at the high Utah desert that the MDRS is at pretty well. We think the lithium power to batteries will also handle these fairly well too, but we've just not made the changeover just yet.
The test one, the test suit that I've got does in fact have a pair of the lithium batteries, and so we will get some experience with that soon.
So the NorCal chapter is currently working on the design of a next generation swimsuit that we hope to be a little more advanced and custom built rather than reusing common hardware quite as much. We do plan on using lithium batteries for that. And we want to have a small form factor computer on board with different sensors and readouts that the crews can interact with. By the way, our suits are just the backpacks and the helmets. And in the case of the one piece, they're all in one piece. But the crews, each of the crews will have their own coveralls, and they generally have a crew color that they have along with their crew patches. And they also have their own boots and gloves. I think originally the MDRS, they supplied the coveralls for the teams, but they got filthy and they never had the right sizes for all the team members, and it was problematic. So they generally made the decision that they bring their own coveralls. So a lot of the suit the crew is bringing with them, and we supply the backpack, the helmet, the airflow system. They also at the MDRS have radio headsets that they can communicate with each other and back with command at the hab. Is there anything I failed to cover? I'm sure there'll be a lot brought up in questions.
Anything besides 20 years of experience? Yeah.
Well, every year we find out problems with the suits for the cruise season and try to make kind of incremental improvements. The two-piece suits, we've had a perennial problem of the helmets fogging up because the airflow, not only do you have to deal with airflow coming in, but in these suits, the air doesn't have a lot of ways to escape. So we added, in the back here, we added a couple of passive vents with little foam filters on them, and to allow the air a little more area to passively push out of the helmet. And this last season, the only time we had a fogging problem was when someone's battery died, and they effectively in simulation died on their EVA. But they did not have problems with fogging as far as the reports went when the batteries were nominal. So yeah, so we've done a lot of little things to improve the suits, and I'm hoping we'll keep improving it, but eventually, hopefully we will be able to present our next generation suit design and get funding for it, and eventually replace these, and maybe they'll be used at some other location.
So as an analog astronaut myself, I first went out to MDRS in 2018. And when I was wearing one of these suits and walked through the airlock for the first time in sim and went out into Mars, although it's Utah, I really felt like I was walking on Mars with a spacesuit on. I mean, the experience was amazing. And so, you know, hats off to you guys for all the work you've done the last 20 years, because this is really, for the people that have the opportunity to come out to one of our stations, you're giving them an experience that is almost identical to what it would be like to be on Mars. And so it's fantastic. So Peter, we haven't heard from you yet. So Peter, as an independent spacesuit designer, what are your impressions of the work that these guys have done? Because I believe you're seeing some of this for the first time. Is that correct?
Oh, I've been haunting the site for years. You know me. Actually, I've done 3-period costume in the past, Halo costumes, that kind of stuff. But actually seeing parts of this size is amazing. I love it, honestly. This is where you start. And the thing is, it's functional. It gives you all the motions you have to have. Helmet on, all the procedures are the same. So yeah, it's brilliant.
Awesome. So at this point, I think we can take some questions from the audience. So the microphone's coming. Well, why don't we go right here?
Guys, I'm so proud of you. Almost every day I get reports on what's going on with the suits and I'm dazzled. Two quick questions. Number
Sure.
one, have you ever considered two-way radios where you can, the astronauts in sim could communicate with two-way radios?
They certainly always do have the radios, but we don't treat them as part of the backpack of the suit. They are provided, they are managed separately. And this year we're having a very significant upgrade of our radios.
Oh,
Yes.
really?
Oh, yes.
Yeah, no, I was gonna buy them all like 8 years handhelds to FRS. I've got a bunch of that now.
And the second part of the question, something original came to mind. Would the two-way radio systems we use here on Earth work on Mars?
I would think so. Judd, do you have a?
I mean, I can understand. I'm a ham operator too.
They will only work for line of sight, of
Oh, yeah.
course. So, and Mars has a closer horizon because it's smaller radius. So they won't work as well as we're used to. There's no ionosphere. So there are many reasons why the radios will not work quite as well. But yes, certainly they'll work.
Thank you very much.
Did I get that? Mark?
Yeah, basically, I don't think we do HF on Mars. Clearly, there's no ionosphere to bounce across. But for line of sight DHF stuff, 2 meters for 40, that kind of stuff, easy. I don't see a difference at all in the slightest.
So you had mentioned the data you're capturing for this year's suits and being able to improve them. Can you talk a little bit about what that data looks like, how you pull it down? Is it real time? And how you're gonna use that to improve the suits moving forward?
I want to make, before I answer your question, I want to make a clarification that the colorful suit is not this year's suit. There's only one of them that will ever be made, and it won't be used routinely. So we have not yet upgraded the suits to that style. There's a Raspberry Pi that is recording, controlling the fan speeds and recording pressure, temperature, and humidity at 10 different locations within the suit. No, at 9 different locations within the box. Those are recorded at 1 minute intervals because running it faster than that would be useless. And I don't know how long because I've got the new batteries that we've not tested. I don't know how long that period would be, but there's plenty of memory on the Pi to record it. And I will analyze it in comparison to the settings on the suit. While using it, I can change the settings through the audio interface, right? And then that is also recorded in the same data stream. And I'm just dumping into a very large CSV file and importing it into a spreadsheet in a MySQL database after I'm done.
Other questions? Yes.
I had a couple. Does this, the information you're generating, is this useful information as a database for eventual suit manufacturers? Part 2, are there any suit manufacturers hypothetically coming to you? And number 3, is there anything that you have wanted to model that you haven't been able to because you haven't been able to produce a part, or what is there anything you haven't been able to model that you want to be able to?
For the history of the suits, for the history of MDRS, we have never had quantitative data. We have lots of subjective feedback about this particular design doesn't work or does work. And Scott's done a great job of reacting to that feedback, but we've never tried to measure pressures or temperatures. So we really don't have any knowledge of quantitative specifications for any future suit. Now that we're working toward moving to a new set of suits, hopefully we can do that with quantitative specs. And then that's the whole idea of the metal one-piece suit, is that it will give us that baseline.
In the back there.
Thanks for taking my question. I was listening to how you said that you created the helmets from trash can lids, and you said that's worked great for 20 years. And I think it's brilliant that somebody thought that a trash can lid could be an integral that's what I'm trying to say, integral part of the analog astronaut experience. But, is it right to assume that you patented that design? And if you did patent it, I mean, is like the trash can lid part of the prior art on your patent?
I'm sure the company that makes the trash can lid
Rubbermaid.
has a patent on it.
Rubbermaid faces.
The original suits at the MDRS and FMARS, the helmets on those also had trash can
Yeah, they were
lids.
exactly this.
So, well, it wasn't the exact
Okay,
same
good.
trash can lids. They were a little bit smaller. In fact, the very reason these helmets are so large is we couldn't find a smaller trash can lid. And that was our limiting factor. It's kind of sad, but so actually for the next generation suit, we want to make the helmets a little bit smaller. These are kind of bulky for what they need to be. But yeah, this was a kind of a case of making do with what parts would work well for this design. And we were very time limited when we originally came up with these. So we were kind of trying to take the earlier design and try to improve it where we could, but not just redesign it from scratch. So we replaced the Tupperware containers in the backpacks that was holding the air pressure chambers and replaced it with a Pelican case, which is much more robust, a bit heavier too, but it's much more robust and can handle wear and tear and impacts, from accidents and such without much problems. So we tried to make use of the existing ones, and a lot of that, or the existing designs, and a lot of that was we were under quite a time crunch. So we did the best we could. The backpack frames on all of these, I believe, are military style backpack frames that we just got.
Ones?
They're Molly 2.
Okay.
So they're not currently used by the military. I think they're a bit out of date, but they are ergonomically designed for
The same one.
heavy
actually.
backpacks. Use the same. ones
Yeah,
as well?
I was from Goodwill.
Well,
Aluminum, right?
They're relatively inexpensive and
No, it's
easy
little
obtained. They're
bucks.
very robust, and they are ergonomically designed for the military.
One of the fun aspects of trying to keep this as cheap as we can and using off-the-shelf parts is that we outlive the parts. When we first started using the storage bins, of course, they were perfect. And when we first started using the trash can lids, they worked perfectly, but now the trash can lid is hard to find. So the advantage of using the cheap off-the-shelf part diminishes. And all of this design happened before 3D printing was widely available. So moving forward, of course, we won't be quite as reliant on creatively reusing existing things.
I think we have time for one more question, and then we're going to transition to Peter.
Okay.
Go ahead there.
Hi. This is not an engineering issue, but a spacesuit issue. I don't know if you guys have run into this, but those of us interested in exploring space are happy to have a spacesuit. But a lot of times when I talk to regular people on the street about this, colonizing Mars, and they hear, well, you've got to wear a suit outside, forget about it. But it occurred to me not long ago that our bodies have a spacesuit. Our skin and our lung apparatus, our cells are all happily floating in a saline solution that they evolved in millions of billions of years ago. So I've never heard this before, but I wonder how many people realize they think of this Earth environment as the Garden of Eden, the optimal environment. This would kill us within minutes if we didn't have this suit that we wear every day. So I just wondered if you'd ever heard that and if that would be helpful down the road somewhere.
Yeah, that's very interesting to think about. Our bodies are designed, we have evolved for billions of years into this environment, and our bodies are not perfectly designed, but handle it pretty well for the most part. I would hate to be out in Death Valley on a hot day, but for most of Earth, it handles pretty well. But we are not evolved for the environment of Mars. There are so many things there that will kill us if we're exposed for probably a very short period of time. Temperatures alone, the radiation over a longer time, the atmospheric pressure, you know. So there's a lot of factors, and yeah, the suits we designed are kind of the best we can do in a reasonable budget and technology level to simulate the suits that they would wear on Mars, but they're probably not, you know, perfectly accurate, the weight or the sizes and shapes of everything. But we're hoping to simulate it the best we can.
But what I think people don't realize, and I didn't realize, despite being interested in space my whole life and being a physician, is that our bodies really haven't evolved that much. Inside this skin and outside of our lungs, we're just basically saltwater creatures that are wearing a suit and a breathing apparatus. And so I think if more people maybe understood that, they'd kind of understand this isn't so far from what we do every day.
All right.
Yeah.
I think that's a good point.
I agree. Absolutely. Good point. Okay, awesome. So we're now going to transition to
Okay.
Peter's talk. Peter, I think the first thing, and thank you guys so much for the work you've done. So Peter, I think the first thing we got to do for you is kind of, you're going to model your suit here. So let me,
Should we bring our things out of the way, or
Inflation,
You
then
don't have to.
PowerPoint, or vice versa?
I'll take
Which
this
one
off
went
the
first?
table?
No choice. Deal.
so Peter is, as I mentioned, Peter is a mad scientist type. He's an independent inventor. He's actually been a contributor to our virtual reality project as well. He's a VR expert. I remember him giving me a tour of Neos VR in real time, and he has a full scale model of the ISS that I got motion sick in VR.
So bad.
But so what he's wearing there is a suit that he invented himself, and
Kind of. Kind of. My own design, but I'll get that in a minute. Make us get chair here.
so he's going to inflate his suit.
I'm sure you might, so what I should do is I got a microphone. Look at the other microphone first. Get my palms here.
Okay, well, yeah, like I mentioned, you know, Peter's one of those people that, you know, he's working all the time. He's got a million ideas in his brain, and there's not enough time in the day for him to implement them all. But, you know, I think it's a great compliment to the discussion we just had about the MDRS suits, because as you can see with the work that Scott and Judd were talking about, we are trying to push the envelope here. We are trying to make it so that our Mars simulations at our analog facilities are as realistic as possible, but at the same time as cutting edge as possible. And that we're using, you know, yeah, I'm not really aware of anyone else that's doing this type of work. You know, there's very few people out there that have the ability or desire to do this. And so we're really blessed to have the NorCal chapter helping out. And here comes Peter again. Shoot over to him. So Peter, what are you doing right now?
Audio link. You can't even get a helmet, so I gotta create one. Come on, there we go. We're gonna see if IKEA. Who knows what crystal motives are? There you go. Okay, that's nice work, I think. It's not bad at all the side. It's not bad for a really bad mouse. Like, there it is. So, okay. Let's grab these two gloves. That's on. That's on. My whole bottle, please. So look at this little suit here. It's basically based on design from Karen Smith, who packed spaceflight many years ago. I worked with him on a high altitude suit and designed him his first ever scrubber. And this is a result of all that research.
Hopefully those of you on Zoom are getting a good view of this. What are you
Hello?
doing right now, Peter?
Put on the restraints. So these can handle up to 800 PSI according to the manufacturer. Put a lot of suit. So far, in the last 6 months, I have spent over a day in this thing in testing. And
The difference between his suit and the MDRS analog suits is that we do not pressurize the flight suit component. So we're just wearing the helmet and backpack over some regular coveralls or flight suit. Whereas what Peter has going on here is more realistic as to what a real astronaut would wear. And so what he's about to do is he's basically hermetically sealing his gloves on so that no air can escape.
can I pinch the air, please? We'll start there.
I'm sorry?
Can I pinch the air, please?
Sure.
That's it, just try to pinch it. Oh, cool.
I was just helping him. Turn, put the pin in his wrist collar.
Unclear, I think it is. That pin goes there.
Hey, Judd. He needs help. Can you help him?
Yeah. Thanks. Red's in the middle and turn to the green.
And it's pretty normal in our sims for when you don or doff a suit to have a buddy. So this is pretty realistic, actually. Usually in space, yeah, it takes an hour or more. So he just did that in about 5 minutes.
There you go. So basically what this works is inside of here is an undersuit that has canvas and independent material. The material is intended to go from pole to pole. Excellent. It's still fitful even at 2 PSI. Well, let's say, yeah, that's how the presentation better. Yeah.
Fantastic.
No, it's presentation time now.
Yes, it is.
Okay, dressing for the consumer space race. Well, we see how Elon Musk has managed to really cut the cost down for rocketry, right? Almost 100-1 ratio in some points of time. Well, let's do the same thing. Oh, Thanks. So the past is not cheap. According to what I'm reading, 200 grand in old money to even cost $20 million in some locations for a spacesuit. But why? Well, LCW made the suits, and Hamilton and Sundstrand made the backpacks for the Apollo era stuff. And so back in 2018, I met Dr. Smith, who's an anthropologist from PSU in Oregon, and he builds low-cost spacesuits. He's been on the Wire magazine, has done 2 TED Talks on it, and taught me how to build the suits. And I spent about 2 years with their team helping them out. I designed a scrubber that was based on, I had as a concept I had based on the design of the original Apollo scrubbers. And that one was 3D printed, then tested out in a Cessna, 3 hours on its oxygen cylinder, and it worked as designed from day one. We were going to build a metal version, we ran out of money. So that was the end of that entire team and process at that point in time. So build my own suit. This is the coolest thing the world ever cosplay as. I do cosplay, I'm also electrical engineering technician. I do aerospace work. And so for me, it's like, what's the ultimate combination of cosplay and actual engineering? Actual spacesuit. And Savage has some, right? But as far as I'm aware, none of them actually seal and have a scrubber or whatnot. Mine does. So the goal was kind of less than 10 grand. So let's cut the hose or the cord. Cameron suits or IVA suits, kind of like the ACs or Sokol, the what you find for like the Russians and the Soyuz capsules or things like the shuttle program. Mine, unlike the IVA suits, is an EVA suit. And the backpack is right there, and that's actually the most important part. So how it's made. The hide is. Why the hide is? Well, because honestly, it's cheaper than buying it from Joann's. And also, on Mars, you can be seen. I mean, obviously an orange base too, look horrible on Mars. This still easy to find, right? You match your environment. That's actually the most important part, basically. And so that little part you see in front of you was $1 grand in total cost to manufacture. Everything on this part of the suit. The inner layer, or PGA, is, as I mentioned before, canvas bond to a polycode nylon. This stuff is just heat bonded at the end of the day, using a clothesline from the 60s. And I use some glue to help seal some of the seams. And the joints you see, those little like black bellows things, aren't actually bonded to this suit. They don't hold any air. It's simply a guide, internal bladder. This way you're not actually going to have all these joints, have all these little seams. It's just a bladder and then a constraining device, so to say. And so far on my shoulders alone.
Oh, thanks. Hey, drop the mic moment, you know.
Thank you for that. But the range of motion I get, I don't have much rotation this way, but for actual range of motion, just fine. So here is the business end. It's a scrubber, similar to which you might find for like a scuba diving system. But here's where all the fun begins. Behind door number 1. Nope. Tired, sorry. This is $2,000 of R&D. The top part is the scrubber. Air goes in on the big hoses, out, just like this. I have 2 plugs here and some in the suit. Same kind of concept. And all inside here is soda lime. And 2 computer fans, actually actual fans. You'll find my server. A 20-volt drill battery and a buck module you find for like, power supply stuff. Simple. Next, please. Yep. Actually, a little more. Yeah. Oh, is that all you have? Shouldn't be.
No, there's 6 more.
Okay, cool. So, first light. 2 weeks ago, this happened. I finally got the actual I/O ports installed, put on the backpack, and for about an hour, ran around the outside of my house. No CO2 problems, no real issues with thermal problems once the undersuit was on full cooling mode, and I could walk around in what amounts to a fully functional spacesuit. Now, a little fact right here, the A7L suits used by NASA were tested at 10 PSI and they burst that pressure. Mine held 10 PSI over ambient. So that's wicked on the first try.
I think that was the slide you were trying to.
Yeah, I'm sorry, I'm trying to jump around here.
So the Apollo suit is pod for NASA spec.
Yeah, so they run it around 4.5, I'm sorry, 3.5 PSI for an average lunar suit, 3.7 PSI to be exact. And then they use 5 for kind of testing purposes, a little more up to 8 for mine. I ran at 10. Apollo likes to go around 6 and they tested theirs. Last I checked. You had a question? Oh, for ambient. Yeah. So we're getting started. I know from the MDRS crew, they keep on iterating. The same thing is here true. I've been iterating now for a good half of, I think, 2 months alone on this actually. Here's one of my attempts at an arm war. I 3D printed a mold for it, used my lathe to spin coat silicone and also some material into it and create my own pleat. This right here burst at 30 PSI. $10 in materials for an arm gore, for a joint. So goals, no pressure. Get it fully vac tight. Right now at full 3.5 PSI, this thing consumes like 4 CFM. That tank should last 3 hours metabolically. It lasts around 45 minutes to be exact, because I got leak problems. At lower pressures, it's not such a big deal, but get it sealed tight. Now, a friend of mine, I can't mention his name, has mentioned it's a good chance I can go to NASTAR and I test it at altitude chamber to 80K feet. And that's my next goal, is to get that prepared and just sit in there for 3 hours and just chill and run it through. Next, please. So he doesn't notice yet. My end goal is to go to his hab and then ruin this suit, not necessarily intentionally, but I want to spend a week there if possible, or 2. And when they use their suits, I'll learn mine. If mine fails, I'm a casualty. And I want to know, can I mingle with the best established and see how this holds up? Much of the power, though, is easily usable. I mean, the neck rings, for example, these are from a pressure cooker, 30 PSI rated, right? Plenty of pressure range for a neck ring, like $30 from Goodwill. That's it. It's that simple. So they're all metal parts you can reuse. The bladder itself, you throw away, but everything else, clean it off, reuse it, it's metal. So I didn't do this whole method instead. An honorable mention to the next slide, please. The hardest part of this suit wasn't really building it. It was finding suppliers who wouldn't get in my way, to be honest. The oxygen was the hardest part, by the way. That was a nightmare because they freak out if you want to get oxygen other than welding. For good reason, I guess, but still. These folks were all pivotal to help me kind of bring these together and make it all possible. And really, this is all Q&A. I want to hear from you all because I really don't have a college degree. You're all the geniuses out here, seriously. So pass it around.
Question.
Yeah.
Nice. This is a great step forward. What are you doing for environmental control and temperature regulation inside the suit?
So Canopy Cooler makes a thing called, you can buy his backpack and the undersuit for $400. It has the same plugs that NASA uses, the little tiny CVC plugs. So this is literally a black spandex onesie, it has tubes in it. And then a pump and a backpack here for this mode. Normally it goes to that silver box down there, which is the on backpack cooler. It has its own plugs. So I can transfer from, temporary cooler or a handheld cooler to the backpack one. And same thing with the auction too. Oh, and more accurately, if I was building a vacuum tight suit for actual Mars, I use a sublimation device. That's why it is, because you can't use sublimation on Earth for right now. That's a temporary standing right now.
Have you considered using a smartwatch in exercise mode to do the blood oxygen level, fitness, heart rate, all those things,
Absolutely. The next thing is to add sensors. I'm a ham operator. I've already put APRS on my transmitter. I'm also gonna be adding biomedical stuff, via I2C, like sensors, that kind of stuff. And that's all next gen. Absolutely. And biomed too. Heart rate, CO2, the works. Go ahead, Jeff.
All right, Peter. So if we're understanding this correctly, not only have you created a spacesuit, you've also made a backpack and a comm system, and you've made it completely movable and almost completely airtight. You can also hold more pressure than a spacesuit built by NASA. You've done all of this using off-the-shelf components.
Yeah.
And instead of having hundreds of people to help build that suit, you've done it all on your own in your garage.
Yeah.
You've taken the price of a suit from at least hundreds of thousands, but if you include the backpack systems, everything else, millions.
20
and you're
million. at least, they said.
essentially doing this. It's not complete, but it's very good. And you're doing it for under $10,000, right? Is that, you with me so far?
Exactly. If you know history of suits, I'm at Gemini in actual kind of mobility range with the functionality of Apollo for the rebreathing section. So that's kind of your tech level right now, is that kind of aero stuff.
So first of all, I want to give you a round of applause because that's absolutely bloody amazing. Secondly, the big question, right? If somebody took this into space right now, what would happen to it? And what would you need to do to make it actually compatible for space travel?
Add some insulation. Right now, it's just two pieces, just two layers, the outer cover plus the inner bladder. And you add some mylar to add the buffer. But everyone knows that. It's trivial stuff. You just sew it together, done. Waste of time to even build for Earth, honestly. Fix the leaks. That's it. Fix the leaks and pressurize it again. Do it. Thermally, I'm not sure I can handle minus 200 degrees Fahrenheit and all that kind of stuff where things might creep and crack and O-rings go bad. But for the temperature ranges we have here on Earth, the parts don't expand or contract too much. I'm not a mechanical engineer in all the slides. I'm an EET who dabbles in 3D printing and a lot of machining on his free time. So.
In the back.
Yeah, this is pretty impressive. How much does it change when you've got it set at 15 psi above ambient pressure as far as the balloon effect of the suit and
It's not that
flexibility?
bad at all, surprisingly. I thought the hard part of the knees, I knee joints at all in the slightest. I just haven't bothered yet. I don't need to, honestly. But for the arm part, I mean, I can move around. The range of motion doesn't decrease at all. It becomes harder, but there's no like locking problems at all in the slightest. And honestly, between 1 and 3 psi is, you can tell it's there, but it's kind of marginal gains, honestly. Once you get under pressure, it's just kind of the same thing.
Time for one more.
So Peter, when we were talking on the Seattle Zoom session, we talked about you heating and cooling your extremities in space. You still need a full heating, cooling suit to do that. And James, you have video of him donning this on those sessions, so you can pull those out. But before you step outside, you still need to address that. One, your extremities are just going to get too cold without that.
To an extent, I'm making the assumption of on EVAs on the dark side of the moon, it's just hot. You're battling heat, not cold. So cooling is easy to do. Heating is also electrical elements, honestly. So those are all things that are easy addable if necessary for an actual mission, but are kind of assumed at this point in time. The cooling part's done. That works very well, just ice water. But heating, not yet.
And Peter, from what I understand, you've also developed a VR haptic that does cooling.
Well, the same undersuit I bought, and Jeff is part of this too. This is a whole like Kevin Bacon thing happening here. So I helped develop a smell vision device called Cilia for haptic solutions for CES earlier this year. I was going to smell in VR. And so that can output motor controller bolsters, right? To change fans and blow some smells. I wired that into this exact controller right here. And now I can be in VR. If I collide with a boundary that has cold in VR, it makes me cold. And it's really crazy. So the suit has other things you can do with it too, as far as like the parts you use. The one thing I've noticed with this whole thing is that the complexity is there. The most of it really is just honestly detailed work and just detailed work. You gotta show your work is detailed, but it's not that hard to build. It really isn't.
Thank you so much, Peter. This talk was certainly a first for our convention. Thank you so much.
And I do want to say I have enough balls of oxygen to 2 more runs. You want to see it later on in our day. I can handle that. So even scrub too. I brought some scrub material too. I want to try it. Yeah.
Right.
So I'm kind of tired. Sorry.
Thank you so much.
Thank you so much.
Thank you.